Well, good afternoon. Thanks for staying for my presentation, which is more on operating. Hopefully, it'll be just as interesting as what happened in the ARRL forum. I think that was very worthy doing that kind of stuff. So, I'm Carl, K9LA from Fort Wayne. And what I'm going to talk about is, let's see, how many techs are left in here? Any? Well, shoot, okay. Well, that's the way it goes. It was kind of focused on technicians, but I think you'll probably get something out of it anyway. Okay, what we're going to address is something basic stuff. What's a solar cycle? Why are they important? What did all the previous solar cycles do? What's cycle 25 doing? And then some simple antennas for the higher bands, 15, 12, and 10. And what can we do on these higher bands when solar cycle 25 really gets going? Okay. Has anybody here been licensed less than 5 years? No? Well, one, okay. Of course, the issue with that is, well, if you've been licensed less than 5 years, you probably wonder, what's so great about 15, 12, and 10 meters? Because if you tune there, it's mostly noise. But when we have enough sunspots, you will find that those 3 bands are great. You can work the world with modest power, 100 watts, and modest antennas. And speaking of antennas, as you go higher in frequency, the antennas get smaller, so that helps a lot too. So here I was going to show, what privileges techs have and generals have. On 15 meters, techs only have CW. Interestingly enough, there's several thousand novices still out there in the world. They haven't upgraded, and they're not going to take it away. So there's some novices, but they have very limited privileges on 15. No privileges on 12, and they do have some better privileges on 10, especially phone from 28.3 to 28.5. General, of course, opens up quite a bit. 15 meters, lots of phone, lots of RIDI and data. CW is part of data, so don't think CW is being excluded. 12 meters, generals have a lot of privileges, and 10 meters, they have basically the whole band. So why is a solar cycle important? Well, it's also known as a sunspot cycle because we measure sunspots, and that's how we define a solar cycle. A solar cycle is the time from a low period of sunspots up to a maximum period of sunspots and back down to a low period. On average, that lasts about 11 years. On average, the rise time is about 4 years, and the decline is about 7 years. Why are solar cycles important? Well, they're important on the higher bands because when there are more sunspots, there's more extreme ultraviolet radiation from the sun that ionizes the F2 region, which is responsible for most of our long-distance contacts. Now, sunspots and solar flux, 10.7 centimeters solar flux, are just proxies for extreme ultraviolet. So just remember, it's the extreme ultraviolet that really does the ionization, does the hard work. The more sunspots, the more extreme ultraviolet we have. And that's the best propagation on the higher bands. And that's where I've, on that chart there, you can see where that is for 15, 12, and 10 meters at solar maximum. Sunspots are important for the lower bands, like 160, 80, 40, 60, and 40. When there are less sunspots, the ionosphere has less absorption in the D region, down low, that's the region that absorbs our signals, mostly during the day. Solar minimum has the least amount of disturbances from the sun. So that's the best propagation on the low bands. And I've indicated on that chart that solar min is great for the low bands. Doesn't mean there's nothing you can work on the low bands at solar max. You may have to spend a little bit more time on the chair to do it, but it's possible. Okay, what did the previous 24 solar cycles do? Here's a Excel chart of the maximum smooth sunspot number for the past 24 solar cycles. Cycle 1 started in 1755. That's when scientists realized that, hey, that's probably when our good data started. Back in the early days, of course, how good were telescopes? Did people count sunspots the same way? All kinds of interesting things. And of course, humans count sunspots. So there can be some bias in how you count. It's interesting to see that. Now, you've probably all heard of the Maunder minimum. That's when we had few sunspots. That occurred from 1645 to 1715. Even I wasn't around back then, so okay, there we go. Now, what's obvious from that plot is we've gone through 3 periods of big solar cycles, right? Cycles 1, 2, 3, 4 were kind of big. Cycles 8, 9, 10, 11 were big. And cycles 17, 18, 19, 21, 22, 23, they were kind of big. What that also says is we've gone through 2 periods of small solar cycles. Cycle 5, 6, and 7. Cycle 6 was the smallest in recorded history. There's probably been some smaller ones, but we don't have any data on them because sunspots have probably been going on for thousands, tens of thousands, hundreds of thousands, millions of years. The next period of small cycles was 12 through 16. It wasn't as small as those first ones, but they're still pretty small. So, cycle 21 I indicated because it's kind of an anchor point for a chart that's coming up. It was a moderately big cycle. You can see it was pretty high. It was kind of close to cycle 19, the biggest in recorded history. How many operated during cycle 19 here? Oh, you guys are 58, 57, 58? Yeah, okay. We're all too young, I guess. Okay, I got in on the decline of cycle 19 in late 61, so kind of missed the good stuff, but that's okay. I didn't know any better. And ham radio was so new that anything I worked was great. In fact, W6 and W7 stations were DX back then for me. Yeah. Well, even Wisconsin was kind of DX, whatever. So that's the big, and then cycle 23, that's about an average cycle if you take the average of all 24. Again, that's an anchor point on a chart that's coming up. Cycle 24 is the last cycle we had. It peaked in 2012, 13, 14, and then went downhill. Cycle 24 is the smallest in our lifetimes. That's pretty obvious by that chart. If we assume that cycle 19 onward is where most of us have been. Well, just about all of us, in fact. Smallest in our lifetimes, and it's the 4th smallest in recorded history. So that's a pretty small cycle. And that's the question. What's 25 going to do? Is it going to keep us in this period of small solar cycles? Or is the sun going to do something spectacular and do a lot better? So that brings us to, well, first I thought I'd throw in, I mentioned the solar cycles in approximate 11 years. You can see on the previous, this chart here, that there are other cycles of solar cycles. You can see there's, what's the period of the big periods, that kind of stuff. And in reality, a solar cycle is really 22 years because the sun's magnetic field flips at every solar maximum. So really, to get back to the original, it takes 2 solar cycles to really do it. And that's important because magnetic fields are very important in our understanding of how sunspots are generated. That 80 to 100 year, that's the period between the maximum periods or the period between the minimum periods. There are even longer cycles when people look at proxies for sunspots. And that's those 2 cosmogenic nuclides, beryllium-10 in ice cores and carbon-14 in tree rings. And here's a chart I thought I'd throw in. That's solar activity back to 800 AD. You can see there's the Maunder minimum, but there were minimums before that. And what that is carbon-14 in tree rings. When it's positive, that means the sun's magnetic field is very strong and it keeps galactic cosmic rays out of the Earth's atmosphere, and that does not generate enough carbon-14. So that's what makes it a solar minimum period. Now when that carbon-14 is negative, that's solar max. That means that we see a minimum or a maximum in solar activity. And you can see there have been many other minimum periods, not as big as the Maunder minimum, but it's very cyclic in nature, and that's probably how the sun's going to work for quite a while, until it gets so big it engulfs the Earth in a couple billion years. The bands probably won't be too good then, I bet. Okay, so how's cycle 25 doing? Well, here's data. We have 27 months of data on cycle 25. 27 months is about 2 years. So that means we're about halfway up cycle 25, since the average rise time's around 4 years. Cycle 25 is in red, okay? The green plot is cycle 24, the one we just went through, the smallest in our lifetimes, the 4th smallest in recorded history. Orange is an average cycle. It's like cycle 23 was. And the blue plot is the moderately big cycle, 21. So it's kind of obvious where cycle 25 is right now. It sure looks like it's going to turn into a small cycle, maybe a little bit higher than 24, which that's okay. We'll take that. Well, we have to. There's not much we can do about it. Like it says there, it's not likely that cycle 25 is going to be very big, unless the sun, just does something out of the ordinary, at least based on the 24 solar cycles we've seen. That's a pretty small sample size, so who knows what's going to happen. A regular pattern.
Or was it an exceptional?
Well, the fact that it's the biggest in recorded history is exceptional. It rose a little bit faster than normal, and of course 25 appears to be rising kind of similar to a small cycle, so kind of says that we're going to have a small cycle. But okay, so what kind of antennas can we use? Because cycle 25 is still going to go up a little bit, or maybe a bit more. And when we get enough sunspots, we're going to have a lot of fun on 15, 12, and 10 meters. And what does that mean? That means those bands could be open every day, consistently, worldwide. And you'll be able to work stuff with modest power, 100 watts, and modest antennas. So let's look at some modest or simple antennas. For 15 meters, well, if you got a 40-meter dipolar inverted V, you can use that. It works as a three-half wave antenna. I know a lot of novices in my day, we used our 40-meter inverted Vs on 15 meters. It worked really good. It's got a bit of gain. One of the problems is the resonance on 15 meters will be above the band. The top plot is 40 meters. You can see that it was cut for right the middle of the band. That's the SWR minimizes at 7.15. When you go up and do the SWR on 15, you can see it's up around 21.8. Well, that doesn't help, right? Right. So what that means is the solid state rigs of today will probably need a tuner, whether it's external or internal. The 40-meter inverted V will work real good on 15 meters. Back when I was a novice, they were all tube rigs, and they had a pi network that could compensate for that SWR, and it wasn't a problem. You didn't need a tuner back then. Now you can use a vertical with a couple, 4 elevated radials, or even on-ground radials. I have a Hustler 4 BTV, 4-band trap vertical BTV. And it gives decent results on those bands, and I've used it playing around in ARRL DX contests. You're not first in line to work somebody, but you can work them. Or you could just put up a dedicated 15-meter dipolar inverted V. The overall length's only about 22 feet, so that's getting kind of small. That'll fit on a small property lot quite adequately. Another antenna for 15 meters. Remember I mentioned the higher you go, the smaller they get? Well, how about a 2-element Yagi? 2-element beam. A driven element and a director. It's got about 5 dB gain over a dipole, which means that's about an S-unit increase in signal. Of course, you'll need a rotator because it'll have less radiation off the back and off the sides. There's a pattern of a 15-meter Yagi. You can see the front lobe is very strong. The weak lobe is weaker. So you do need that rotator. And if you put it up at a height of 30 feet, you'll have a heck of a lot of fun. And there's the dimensions. The boom is, it's about 5 feet. Elements are 22 feet or so. That's not too big, but it'll work very well. What about antennas for 12? Well, they're getting smaller. An inverted V or dipole is only about 9.25 feet per side, 18.5 feet overall. That's getting pretty small. You can make it out of wire, aluminum tubing. The 2-element Yagi could be scaled from the 15-meter dimensions on the previous slide. And it's pretty small. Even you can start thinking about a 3-element Yagi for a little bit more gain. What about 10 meters? Well, even smaller. Dipole's only about 16.5 feet tip to tip. That's pretty small. It'll give great results at 15 to 20 feet, so you don't have to get it up too high. Maybe you got a chimney on a house. Put a chimney mount, TV antenna chimney mount, and put the antenna there. Multi-element Yagis are quite reasonable. I have a 4-element Cushcraft 10-meter Yagi. It's got a 16-foot boom, 4 elements, and each element's about 17 feet, tip to tip. I bought it when we lived in Texas in 1980, and it worked great for me in Texas, and also it works great for me here in Fort Wayne. And I used it to work a lot of stations with my little homebrew 250 milliwatt sideband transceiver. So I had a lot of fun with that. And there's the pattern. You can see what it, nice big forward lobe, not much radiation anywhere else. So you definitely need a rotator, but it sure helps to have something like that. How about 6 meters? Well, we're getting even smaller and smaller. A multi-element Yagi is very doable. I have an MFJ 1762. That's a 3-element, 6-meter Yagi. The elements are about 9 foot long. It's on a 6-foot boom. Weighs about 3 pounds. I mean, a little TV rotator will turn that, no problem. It's got great front to back, as you can see by that modeled pattern. It has very little radiation off the back. So what do you do on 6 meters if you get a sporadic E opening? The band's open in many directions. Well, use another antenna. I've used my 40-meter inverted V on 6 meters, and it works great. If it's a good sporadic E open, it'll work. Okay, when are the higher bands open? When are they going to be open? And what can we do on those bands? Well, propagation on 15, 12, and 10 basically follows the sun, okay? Look to the northeast through the southeast during the mornings, to Europe, Africa, Caribbean, South America, Central America. Around local noon, kind of look from southeast to southwest. Africa, Caribbean, South America, Central America, Australia, and New Zealand. And later in the evening, look to the southwest through northwest. Again, Australia, New Zealand, the Pacific, Japan, Southeast Asia, Far East. That's a good general rule to just remember. Okay, what can you do on the higher bands? Well, one of the reasons there's ham radio, according to the FCC, of course, emergency communications and public service is a biggie. But there's also, it says, there's Part 97.1E, continuation and extension of the amateur's unique ability to enhance international goodwill. So, get on these higher bands, and have a good rag shoe with somebody, out of the continental U.S. You will enhance international goodwill. Now, I don't think you'll talk to that guy on the right, but okay. There can be some guys who are just as interesting, though, but that's okay. Yeah. Okay, yeah. Yeah. More things to do. Part 97.1, another reason why there's ham radio. Expansion of the existing reservoir within the amateur radio service of trained operators, technicians, and electronics experts. So that's another reason for ham radio. What you can do is do some contesting or go after rewards. There's Worked All States, that's a very popular one. DX Century Club, you work 100 countries, that's very popular. Worked All Zones, that's a kind of tougher. The world is divided into 40 zones by the CQ people. You can work all 40 of those. Enter contests. A good place to start is the state QSO parties. The Wisconsin State QSO party is in March, so you got to wait a while for that one. Illinois is coming up in October, I think it's 16 and 17. That one would be a good to get into and have a lot of fun on all the bands, mostly on the lower bands. There are other friendly contests like North American QSO parties, where the exchange is your name and your state. That's kind of friendly. It's a lot friendlier than 599 something, or or on phone 5904 your zone or whatever. So there are lots of things to do. So here's some references. If you want to learn more about propagation, take a look at the propagation chapters in the ARRL antenna book and the ARRL handbook. Bob Brown, NM7M, he was a professor of physics at Berkeley in California. He wrote a book called The Little Pistol's Guide to HF Propagation. It's written for, people who aren't, who just need a basic understanding of what's going on, don't need to get real deep into ionospheric physics. It's out of print, but it's available on my website. It's a 15 meg download. It's free. If you want to learn more about antennas, go get the ARRL antenna book. It's got all kinds of antennas, from verticals to dipoles to mobile whips, VHF, UHF, everything. Lots of canned designs for 30 meters through 6 meters, even some 2 meters, I guess, and probably 40 meters if you want to get really big. And there's a list of some references for solar info. There's lots of stuff there on the web. And what I think you should pay attention to is SFI, which is the 10.7 centimeter solar flux index, SN, the sunspot number, and K, the K index. For the higher bands, which should be getting much better soon, we desire high solar flux index and a high sunspot number, but we want a low K index. Now, the K index varies from 0 to 9. 0 is very quiet, 9 is disturbed, and it tells us how active the Earth's magnetic field is. If the Earth's magnetic field is active, it can screw up the F2 region. So that's why we want the K index to be low. We want the F2 region to be stable. Spaceweather.com. NOAA has their website, swpc.noaa.gov. VE3EN has solarham.net. N0NBH has a banner at QRZ.com. You've probably seen that millions of times. It's all over the net. And it tells you the SFI, the sunspot number, and the K index, and a lot more. Like I said, as a first pass, know what the solar flux is, know what the sunspot number is, and know what the K index is. The K index, like I said, goes from 0, quiet, to 9, disturbed. It's a 3-hour index, so there are 8 of them during the day. If you average those 8, that turns into the A index. You've probably seen that too. And on the bottom, that's WX6 Space Weather Woman, Dr. Tamitha. I always want to say Tabitha, but that's not right. It's Tamitha. And she does a regular video telling about what the sun's doing and how that affects propagation. Very knowledgeable. She's good to listen to. She's a solar scientist, so she knows what she's talking about. Here's some more references. What if you want to know what the bands are doing right now? Any band. Well, there's the top reference is dxmaps.com. Just type that in. What you'll be able to do is select a view. What I've shown here is a world view. It's kind of hard to see it, but you don't need to see the details. I've selected 10 meters, and this was last Thursday morning. You can see those black lines are QSOs between pretty much a lot of North America, East Coast, in Europe, and even farther. And that's for about a 10-minute period. So it tells you pretty much right now, does that band have lots of contacts on it? And if it does, well, you better go up and look and see what's going on. There's some other ones, PSK Reporter, WhisperNet, the Reverse Beacon Network. That's an interesting one. If you transmit CW in a certain format, like test dotted it in your call on CW, you can go listen to software-defined radios around the world and see where you were heard. That's a pretty good real-time indicator of what the bands are doing. Again, here's just a review of what we want the solar flux and sunspot number to be. I gave some representative numbers for 15 meters, and we're kind of above that right now. So 15 meters should offer pretty consistent propagation worldwide every day. And of course 12 and 10 will follow as the sunspot number goes up even more, or the solar flux, which means the extreme ultraviolet is going up too. Generally, we want the K index to be less than or equal to 3. Says the F2 region isn't screwed up too much. So, summary, cycle 25 is going up. Yay, finally. Most scientists are forecasting a small solar cycle, just like kind of similar to 24. Again, solar min's best for the low bands. Solar max is best for the high bands. 30, 20, 17 are kind of in between bands. They're good throughout a solar cycle. And antennas are very reasonable on 15, 12, and 10, and even 6 meters. And all I just want to end with is get active on HF. You're going to have lots of fun. So if there are any questions, I can answer them. Get on a radio. That's why you get your license, right? Right. Yes, sir.
You mentioned the K and the A.
Yep.
What's the relationship between the K and A?
Okay, the K is a 3-hour index. In other words, every 3 hours of the day, WWV puts out, the K index is 2, okay? The next 3-hour period, it's 3, next 3, okay. So there are 8 K indices in a day. If you average those 8 K indices throughout the day, that's the A index. It gives a little bit broader picture, whereas the K index is a little bit more focused. And more than likely what you really want to pay attention to is the K index over several periods. Because, you know, the K index could spike up, but that may not show up in the average of all 8. Yeah. So it's better to look at the K index. Yes, sir.
Propagation book?
Well, I updated the CQ propagation book, the CQ shortwave propagation handbook, 4th edition. You have to pay for that from CQ.
Yeah, you have to pay for that.
Okay. But it's entirely in color, which is pretty neat. I was happy they did that. And I got paid for that. I got 2 books. So that was enough. Anything else? Yes.
I'm curious from your perspective, like in a band like 15 meters, how many sunspots do you need to work that band almost 24 hours in the middle of the night? I know 20 meters sometimes in the middle of the night's a lot of fun. When
yeah. I'm not aware of a lot of 15s open all night. I mean, when we hit solar max for 25, the sunspot number will probably be around, not 100, that means the solar flux will be up around 150 or something. 15 will be open well into the night. And why is the band open well into the night? That's because the F2 region recombines, you know, the positive ions and the electrons recombines very slowly. So the F2 region doesn't, you know, when sun sets, it doesn't go down right quick. It takes a long time. Now, there are places like around the equator at solar max where 10 meters can be open round the clock. During cycle 19, the biggest in recorded history, people reported that. We probably won't see that for a while, but
No matter where I turn my antenna, I was getting into Central Asia.
Yeah.
But how much do you need sunspots? I can't remember anymore when they did that.
Yeah.
That was interesting.
It might have have been cycle
19. Well, cycle 21 and 22 were pretty sizable, so it could have happened then. And it just, when there are more sunspots, it just happens more often. We all got to go to work and do this and that, and we miss a lot of times. The bands are open more than we think. We just don't, we aren't able to get on. Okay, the digital modes, FT8 is kind of taken over the world at the moment. It allows they can decode signals farther down into the noise. Much better than CW, and of course a lot better than sideband. So get on the digital modes. Take advantage of FT8 because it's better than CW. And when the bands aren't really good, you may have lots of FT8 contacts. It's just the advantage of the digital modes. Of course, what you trade in the digital modes is how long it takes to make a QSO. FT8 takes longer to, exchange information than CW, but it can hear better. The best digital mode is, I think, something 65. Okay, yeah, JT65. Man, I went blank there. And it can hear signals way down into the noise, but I think it takes a couple minutes to exchange the information to make a QSO. But that's great, especially when, like 6 meters needs lots of sunspots. But we've had lots of decent openings on FT8 on 6 meters. CW and sideband, we don't have enough sunspots for that yet. But, yeah. Anything else?
Yeah, hi Lance,
Hi.
John. 2 questions. Last week, under, was that the NASA thing or space weather, there was a huge CME that went towards Venus.
Yep.
And they were talking about when that thing comes around by us, but I guess it never happened. What would, there's 2 questions. One, what would have happened to us as far as like satellites, propagation? That's one question, please. And the other one here last week and a week early, the week before, Lance, W7GJ was on Mayonet on 6 meters, EME, and he was held out from working the moon. It was ionospheric disturbances that were holding his signal down, maybe some tropo. What does that have to do with the solar cycle? Perhaps you could elaborate on those. Thank you.
Okay, the first question. Well, a CME is a coronal mass ejection. It's an explosion on the sun. If it's facing, or if it's Earth directed, the solar wind speed increases tremendously. Normally the solar wind, the wind coming from the sun to the Earth is about 400 kilometers per second. I mean, that's pretty fast, but in terms of a CME, that's kind of slow. Because some of these CMEs, if they're Earth directed, we'll see the solar wind, 1,000, 1,500, 2,000 kilometers per second. What that does is screws up the Earth's magnetic field. And when the Earth's magnetic field gets disturbed, the F2 region is screwed up. That's because, remember, the F2 region is, when it's ionized, you got free electrons. It's a charged particle. So it's going to be affected how the Earth's magnetic field is moving around and getting screwed up. So you've heard of the Carrington event, 1859? That was a really big CME. And if it's Earth, something like that hits us directly, we're going to lose satellites. We'll probably lose power grids and everything. It'll probably happen one day. Not too much we can do about it. We'll have a couple days warning, but I'm not sure what we can do. You can shut satellites off, I guess. And I'm sure that's one of the mitigations for that kind of stuff. But something like that's going to really screw up the whole world, and especially, and of course ham radio's in there too, our propagation. The second question, why was there, was that 6 meters or 2 meters? 6, that was W0 GJ? Or W7 GJ? Yeah, Lance. Well, normally, solar disturbances wouldn't affect 6 meters. Wouldn't have, okay. Yeah, I'm trying to think of how that could affect it. I'm sure the moon was on the horizon, right? For that, because, yeah, because you get ground reflection gain, and I think that's helpful.
Because he said in the emails to other people through OM4 KSP that he was saying that he was having problems
Yeah.
because the ionospheric, the signal wasn't going in through the ionosphere out to the moon, and it was being held down and stunted, if you will. So that,
Yeah, I don't think it, you talk about the troposphere, that's where tropospheric ducting occurs, but the inversion depth for that to happen on 6 meters is really big, which I kind of doubt that wouldn't happen. I don't know. Okay. Haven't looked at it and, okay, sorry. Yep. Okay. Well, thank you for showing up, and glad everybody could make it to Superfest. Hope everybody had a good time, and hope you won everything. Everybody won something, maybe. Who knows? Yeah. Okay, thank you.
All right, thank you. Thanks, Carl. I want to thank everyone for attending Superfest this year. I mean, it's the first one in a couple of years, and we're definitely happy to be back doing the show. And I want to thank Carl for making it, allowing us to do this as a Central Division convention again. We really appreciate it. And I want to personally thank you. If I didn't back when MREC had their 100th anniversary for the ARRL a couple years ago, that was the last time we all met. So just wanted to say thank you for that. So please check, if you didn't hear, I don't know if they've done the grand prize drawing yet, so please check that out there. Make sure if your name's on the board or anything. I haven't heard anybody yelling or screaming yet, so I think they're waiting for us to be done. So have a good day. Thank you everyone for coming.